By the end of this lesson, you should be able to explain acceleration due to gravity, state what a gravitational field is, define gravitational field strength. Last week, after physics class, Ali sits under a mango tree and ponders over a physics problem. Why does the moon orbit the Earth? Why do planets orbit the sun? There must be an invisible force that acts between the moon and the Earth. Otherwise, its path would be a straight line and not an ellipse. Yes, why in fact did this mango fall down and not up? There must be an invisible force that acts on the mango to make it fall down to Earth. Could the same force acting on the mango also act on the moon, keeping it in orbit around the Earth? Of course, there must be a similar force that pulls mango, moons, planets, and everything else in this universe. What do you think this force is? Newton had a similar experience when sitting under an apple tree that led him to propose that the force that causes the apple to fall down to Earth is the same force that causes the moon to orbit the Earth and the planets to orbit the sun. Physicists name the force gravity or gravitational force. You have learned that whenever an object experiences an external force, it undergoes a change in motion. That is, it accelerates. What are the external forces that act on the mango as it falls to Earth? Gravitational force and a relatively small air resistance. If we ignore the small air resistance acting on the mango, then we have a condition where only gravitational force is acting on the mango. We call this condition a state of free fall. When this happens, the acceleration of the object is called acceleration due to gravity. The symbol of this acceleration is g. Consider again the falling mango. Although the mango and the Earth are not in contact, the mango is attracted towards the Earth by gravity. The mango is interacting with the field surrounding the Earth and experiencing a force, Fg, acting on it. It experiences a force acting at a distance. This is also the force experienced by the moon orbiting the Earth. Can you see the effect of the interaction between all objects with the field surrounding the Earth? Let's try to analyze the field surrounding the Earth further. We call this field the gravitational field of the Earth. We can represent the field surrounding the Earth by field lines. Now, can you construct a definition for gravitational field? It is a space surrounding a body, in this case Earth, for which another body with any mass in the field space experiences an attractive force. Do you notice how the lines are drawn? Where the gravitational field lines are closer together, the gravitational field is stronger. This means that the field is strongest near the Earth's surface. The arrows show the field direction. This means that an object in the gravitational field of the Earth will be accelerated in the direction of the field line at that location, that is, towards the center of the Earth. What is gravitational field strength? The gravitational field strength is defined as the magnitude of the gravitational force acting on a unit mass of an object in the field. In SI unit, this means that gravitational field strength is the force in Newton acting on a 1 kilogram mass placed in the field. From Newton's second law, we can regard force per unit mass as acceleration. Therefore, gravitational field strength is another name for acceleration due to gravity. Hence, we use the same symbol, g. But remember, acceleration due to gravity is the acceleration in meter per second squared when a body is in free fall. On the other hand, gravitational field strength is the gravitational force in Newton per kilogram experienced by the body for each unit of mass of the body. Is the acceleration due to gravity and thus the gravitational field strength near the surface of the Earth the same for all objects? Let's analyze the motion of a vertically falling golf ball. The state of fall from rest of relatively heavy objects at ordinary low speed is practically a free fall. In the early years, Aristotle, a Greek philosopher, had the idea that heavier objects will always fall faster than lighter objects. In other words, the acceleration of heavier objects is greater than lighter objects. However, Galileo refuted the idea by saying that during a free fall, all objects change velocity at the same rate. That is, they all have the same acceleration due to gravity, and this acceleration is constant. Whom do you agree with? Galileo is said to have dropped various objects from the Leaning Tower of Pisa and found that a stone twice as heavy as another fell at the same time as a lighter stone. He goes on to establish that during a free fall, all objects, regardless of its mass or weight, fall with the same acceleration due to gravity. That is, acceleration equals g.
Consider a ball of mass 0.2 kilogram being thrown upwards into the air with an initial velocity of 3 meters per second. Assume that air resistance is negligible and the ball is in a state of free fall. Determine the velocity and acceleration at each location by filling in Table 1 with the appropriate values.